Hi, this is lesson number 6. This is a lesson I did today, Monday, November 2nd. And I've skipped over the first couple of slides that were about a math talk. And I'm diving right into this slide where it gives you a quick review of some important pieces of information that I want to remind you about. First of all, that we are looking right here at an expression. And an expression is made up, in this case, of two terms. Here's the first term. Here's the second term. I also want you to remember that this is a mathematical operation, and I could have division, multiplication, addition, and subtraction as my mathematical operation. I also want you to note that I have, again, like I said, I have two terms as part of this expression. I also want you to note that there is no equal sign. Okay, that's another important piece of information for an expression. I also want to remind you that we have a variable right here. And in front of the variable, we have what is known as a coefficient. And remember that a variable and a coefficient together means I'm going to multiply 5 times x. That's what that means. And then this 3 is considered a constant. It is simply a number that is part of my expression. So that's a review on expressions. Moving on, the next slide talks about equivalent expressions. So note that I have an expression on the left-hand side and another expression on the right-hand side. And these two expressions are actually equal to each other. So these expressions that are equal, no matter what value meaning what number we use for the variable. So, for example, if I plug in the variable and I say that x is equal to 2, therefore, x is equal to 2 on the right-hand side. And if I actually were to do this problem, 2 plus 5 is 7, and 7 times 3 is 21. That is going to equal, if I multiply 2 times 3, which is 6, and 6 plus 5 is 21. So these two expressions are equal to each other. They are considered equivalent expressions. Moving on, and now we're going to look at equivalent equations. So this means I have an equation and I have another equation. And I am basically telling you that these two equations, they look different. One says x plus 2 equals 7, and the other one says 2x plus 1 is equal to 11. They're completely different. However, they are equivalent. Why are they equivalent? They are equivalent equations because they have the exact same solution, or the solution or the value makes each equation true. So, for example, what number plus 2 equals 7? 5. So if I put in 5 for x right here, basically I know if it's an equivalent equation. If I put in the 5 right here, do I get the same thing over here? Do I get 11? Yes, 11 equals 11, but the value was 5. 5 plus 2 is 7, so 7 equals 7. It didn't mean that this equation and that equation, they're completely different. The value that made x equal to 5, that is what made the equations true. Equivalent equations have exactly the same solutions. So that's what's key here. All right, moving on. Now, based on all that information, which of the following equations are equivalent to one another? So what I would do is I'm like 3a plus 6 is equal to 15, 3a is equal to 9, a plus 2 is equal to 5, 1/3 a is equal to 1. Well, I know that when I multiply 3 times 3, I get 9. All right. And that means that 3 was, so A was equal to 3 in that case. So that means I want to know if A was equal to 3 in all the rest of them. So let me try this one right here. So if I go 3 plus 2, well, yeah, that equals 5 because 5 is equal to 5. Yes. All right, so this one and this one are equivalent. All right, well, let me try the other ones. So if I take A and put in 3, right? So I go 1/3 times 3 is equal to 3/3, which is equal to 1. Absolutely, that works. So that one works too. All right, let's do the last one, 3A. So that means I'll change colors so you know. 3 times 3 plus 6 is equal to 15. Well, this is 9, and 9 plus 6, 15 is equal to 15. Yeah, that works. So which of them are equivalent? They are all equivalent. They were all equivalent. So you should have written that in this box and hit submit. All right, moving on to the next slide. So how can we show? Well, how can we show that 1/3 of A is equal to 1 is equivalent to 3A is equal to 9? Well, again, I'm looking for a value. So what value of A can I substitute in right there that'll equal 9? Well, if I multiply 3 times 3 is equal to 9, so that 3, that means that's got to work right there. So 1/3 times 3 is equal to 3/3, which is equal to 1. Therefore, A in both cases was equal to 3. So it worked in both. Moving on and looking at the next one. So again, we've already done this, but this is just more practice and more review. Remember, we know what value of A plus 2 will equal 5. Again, I knew that A was equal to 3. So that means if A is equal to 3 in this equation, then it has to be in that equation. So again, I can go 3 plus 2 is equal to 5. And 5 is equal to 5. So that works. And now let's go over here. 1/3 times 3 is equal to 1. And 1/3 times 3 is 3/3. And I know that 3/3 is equal to 1. And 1 is equal to 1. It works. So therefore, I've just shown by substituting. So I showed by substituting. And I plugged it into both equations to make sure that it was true. Moving on now. So now we're changing gears a little bit. And we're going to be looking, so we were talking about equivalent equations. Well, we're going to continue to look at equivalent equations, but this time what we're going to do is that we are going to be manipulating or changing equations, and I want to know, is it still true? All right, so let's just start out by looking at this problem. All right, I'm going to read it out loud. So Noah is buying a pair of jeans and he's using a coupon for 10% off. The total price is $56.70, which includes $2.70 in sales tax. Right? Noah's purchase can be modeled by this equation. Remember that 10% is written as a decimal 0.10. So here we go right here. Here's the equation. And I'm going to reread it, and I'm going to write down or jot down some notes here. We know that Noah is buying a pair of jeans. Okay, he's buying a pair of jeans, and he's using a coupon for 10% off. That means he's going to give somebody something, and he's going to get money off. How much money does he get off? He gets 10% off. So I don't know exactly how much money that is yet. Now, it says the total price. So Noah goes and he buys his jeans with his coupon, and he spends a total of $56.70. Okay, so that means he gave the cashier $56.70. And in that $56.70 is the $2.70 in sales tax that he paid. All right, so he buys a pair of jeans. I know he spent a total of $56. That included, that 56 includes the $2.70. I know it's 10%, and here's our equation. All right, so I've got X minus, there's that 10%. All right, because remember it says that I'm going to write it as a decimal. There's my tax, $2.70. There's my tax. There's my total right there. All right, now it says, what does the solution to the equation mean? All right, it's not asking me to get the solution. It's asking me what the solution means. So I'm going to look back at my equation, and what does that mean by solution? Remember, last week we talked about solutions. It's what makes an equation true. So in other words, what is X here? I have no idea. Okay, he's buying a pair of jeans, uses a coupon. So what does the X represent? Well, I know the total that he spent was $56. Do I see how much the pair of jeans were anywhere in this problem? No. The solution, which will be X, the solution X will give me the price of the jeans. That's what it meant. All right. So again, now let's go back and take a look at it. If I have, and I'm going to erase this just real quick. Okay, so if X is the jeans, then here's my jean price. I'm going to take off 10% of the jean price, okay? And then I'm going to add tax. And when I do that, my total is $56. Perfect. That is what I've got. All right. So hopefully that made sense. Moving on to the next slide. So now we are going to look at, verifying a solution. So I'm given two solutions that I need to verify. So let's just read. Again, Noah's buying a pair of jeans. He's using a coupon. Same thing. Nothing has changed here. We know that the total is $56.70. We know that the cost included, or the price that he paid included $2.70 in sales tax. And what else? We also have an equation here. And remember, we figured out that the solution was the value of X, and we were told that it's the price of his jeans. So this is the price of the jeans. All right, now, price of jeans. So now they're asking us to verify that 70 isn't a solution, but that 60 is. So remember what we did. So what does a solution mean? That means that I could substitute in every place I see an X, I'm going to put in 70. So I'm going to go 70 minus 0.1 times 70 plus $2.70. And they're telling me that that is not going to equal $56.70. So let's do the math. 70 And if I use a calculator, I'm going to multiply 0.10 times 70, and I know that that equals 7. And I'm going to then add $2.70. And when I do that math, I know that 70, take away 7, is 63. And 63 plus $2.70 is, does that equal $56.70? No, because look at 63 is too much money and I'm adding more. So this does not work. I can verify that it's not a solution because it didn't, this side is not equal to that side. So it doesn't work. How could I verify that 60 is a solution? Well, I'm going to do the exact same thing. In fact, I'm going to substitute in 60 in for x. So I'll do that in purple. I'm going to go 60 minus 0.1 times 60 plus 270. And does that equal 5670? So I'm going to go ahead and do the math. This is 6. So 60 minus 6 plus 270. Okay. And again, I want to know, does that equal 5670? So what's 60 minus 6? 54 plus $2.70. And does that equal 5670? Does the right and the left? So look at 54 plus 270 is 5670. That is indeed equal to 5670. Check. So now I have just proven that 60 is indeed a solution. So it works. All right. Hopefully you got all that down. Now we're going to go on and look at the next one. So this next slide is asking us to defend or to point out things that were done. And I did a lot of these with the students together. So basically, again, same situation. We're going to take equation A, equation B, and equation C, and we're going to look at it in more detail. So we're going to start with equation A. But let's go back and remind ourselves, what's this story about? What's the problem about? We still have Noah. Noah is still buying a pair of jeans, no different. He's using a coupon. It's 10% off. We know the total price is $56.70. That includes $2.70. We've got an equation right here. All right. And we know these following equations, equation A, equation B, and equation C, are all the same equation. However, something was done to it. And according to this, we need to either figure out what was done, interpret what was going on, and whether it has the same solution. So, each equation is a result of performing one or more moves on the original equation. Each can also be interpreted in terms of Noah's purchase. So let's take a look. For each equation, determine either what move was made or how the equation could be interpreted. Then check if 60 is still the solution. And we're supposed to fill in the blanks. All right, so let's take a look at this first one. So I'm going to go ahead and erase this. And I see that I have equation A. Here's my original right here. We're always going to go back to the original. Okay, I've got x minus 0.1x plus 270 is equal to 5670. Down here I've got, 100x minus 10x plus 270 equals 5,670. So what the heck was done? Well, but I know it says the interpretation of what was done was the price that is given now is in cents. In other words, I could say it's in pennies or cents, right? Instead of dollars. So the way I like to look at it is if I look at X, what happened to X to go from X to 100X? What happened to 0.1X to go to 10X? What happened to $2.70 to get to 270? What happened to 56.70 to get to 5,670? Well, basically, I'm hoping that you noticed that everything was multiplied by 100. And I know that that's a little bit of a giveaway right here, this cents. How many pennies or cents make a dollar? 100. So, do I have the same solution? Absolutely yes. I know that it's the same solution because I simply multiplied the left-hand side by 100. Every single term got multiplied by 100. And what did I do to the right-hand side? I multiplied that by 100 as well. And I could have pulled out my calculator and done that, and it would have shown that it worked. But I'm too lazy, and I just know that whatever I did to the right, I did to the left. And whatever I did to the left, I did the exact same thing to the right. All right. Now let's look at, slide or equation B. So now equation B, again, we're looking at the exact same thing. We go from here. All right, so I'm going to erase this because now we're looking at B. And we have X minus 0.1X is equal to 54. Well, wait a minute. I've got X, and I have 0.1X and 0.1X, and I'm subtracting those right there. Well, what happened to the $2.70? I don't see it over here. So what was done right here is it tells us they subtracted $2.70 from both sides of the equation. Both sides. Remember, I said they multiplied everything by 100 on both sides? Well, same thing here. What was done? Subtracted 270 from both sides. What's the interpretation? They subtracted the sales tax. Sales tax. That's what they did. They got rid of it. They took it away. Okay? Do I have the exact same solution? Yes. Absolutely yes. Why do I know that? Because I subtracted $2.70 from both sides. From both sides of the equation. All right, let's look at this last one, equation C. So again, going back, I've got the same exact equation right here. And now I've got this equation. And the interpretation says, well, that 10% off means I'm paying 90% of the original price. Or 90% of the original price plus sales tax is $56.70. That is absolutely right. So if I take 10% off of something, I'm really paying 90% of the original. If I take 20% off of something, I'm really paying 80% of the original. But what happened in my equation up here? So I'm going to note something. Still have $56.70. Still have $2.70 right there. But how did they get 0.9x? What did they do here to get that 0.9? Well, we know that 0.9 is 90%, but they did something. What they did was they took 1x and they took away 0.1x. In other words, if you take 1 and you subtract 0.1, I get 0.9. In other words, if I have 100% and I take 10% away, I get 90%. There it is right there. So, do I have the same solution? Absolutely yes. Why? Because all I did, and I'm going to draw a big circle around it again, these are like terms. And all I did was I subtracted 1x from 0.1x, and I got 0.9x. That's what I did. All right. So that's 6.3. That's finding the things that work. So on the next slide, slide number 10, what we did was now we have equations that continue, that things were done to these equations that don't seem quite right. All right, so what we're supposed to do is figure out what went on. And we didn't do everything on this page. So let's start with equation D. In fact, we didn't look at equation F at all. So again, here's our original right here. There it is. And here is my new equation right here. All right, so what do you notice? Okay, well, I notice that x and x are the same. 0.1 are the same. And the totals are the same. Okay, but wait a minute. Where did $2.70 go? What happened? We were supposed to, remember, if I took it away, then I should be subtracting it, right? I should subtract $2.70. But this never changed. So what was done? Well, they subtracted $2.70 from the left, but not the right. So if they didn't do the same thing to both sides, am I going to get the same solution? No, absolutely not. Absolutely not. So moving on and now looking at equation E. Again, I'm going to go ahead and erase this so you can see this a little bit clearer. And what do I got? I've got x, okay, and x, so these two match, and 0.1x matches. Okay, well again, where did the $2.70 go? It's missing. Okay, but now all of a sudden, I've got this big number here. I don't have 56.70, I've got 59.40, and if I read this, it said, well, I subtracted 270 from the left. Okay, I subtracted 270 from the left, and I added 2 to the right. Well, so what's the interpretation? Well, they subtracted the tax, but they added the tax. And you have to understand that this price, $56.70, already included the tax. So that's not right. And so therefore, is it going to be the same solution? No. The other way I can say is it's not the same solution because I can't subtract on the left and add on the right. I've got to be consistent, okay? I have to be consistent. So that is what we did today. And on the next 2 slides, I hope that you're able to do those exit tickets on your own, okay? So it says that my time is almost up. So again, I want to know 5y equals 6 represents purchasing 5 tubs of yogurt. So what will the solution mean in this equation? And then on this one, which of these equations is equivalent to this? So make sure you select all that apply. All right, you also have homework, check Canvas, okay? I hope you found that helpful, and hopefully it kind of tied up any loose ends.